Hi, in this session we will finally analyze the power of Laplace transforms. We will be using Laplace transforms to solve ordinary differential equations. Okay, so here we will be using all the concepts which we have studied in earlier classes like taking Laplace transforms, finding inverse Laplace transforms, using derivatives, integrals, everything will be employed in the solution of problems. Okay, so we will be employing all those methods to solve our core problem, which is solving differential equations. So how to use the Laplace transform methods to solve this differential equations, or in particular initial value problems. Okay, so that is what we are going to do here. Okay, so usually what do you mean by initial value problem? You know that initial value problem contains a differential equation would be there. Okay, and also some conditions would be there, like maybe y of some k is equal to some constant, y dash of k is equal to some constant, etc. So this is the usual initial value problem. So how will you solve it? The first thing is you will solve ordinary differential equation using the familiar methods. So if the differential equation is of a linear differential equation, you know some solution techniques will be there, or if it is a variable separable form, there will be some other methods will be there. If it is homogeneous equation, some other variables will be there. So the problem with this that you can find the solution of a differential equation directly only if it is of some form, with some known form. Like for example, it should be a linear differential equation, or it should be a homogeneous equation, or it should be a variable separable equation, or it should be an exact equation. So if it is only of a particular form, you can employ those methods. So generally differential equation will not be of those methods. It can be in any form. So it will not be very easy to solve ordinary differential equation if it is not of any of the methods which you have studied. Okay, so directly solving ordinary differential equation is always difficult. It is easy only if it is of a particular form, like it should be a linear equation or an exact equation, etc. If it is of that form, then it can be easily solved. But generally in applications, the differential equations need not be in the standard form. Okay, so direct solving is very difficult. So that is where the Laplace transform is very much useful in solving the practical problems. Okay, so we will be discussing some of those concepts in this section. We will be taking up a differential equation and we will try to solve it using the Laplace transform methods. Okay, so as I told you, generally for solving the IVP, what you will do is that you will find the general solution, and then you will substitute the initial conditions to find the arbitrary constants. Okay, so in the case of Laplace transform, is that what we are doing is that we can, without using this multi-step process, we can actually directly solve the problem employing the initial conditions at first itself. Okay, so in the normal method, what you will do is that first you will find the solution and then you will substitute the initial condition. But in Laplace transform method, what is happening is that the initial conditions will be employed in the first step itself. So when we do the problems, you will understand what do we mean by this. Okay, you will understand this method when we do the problem. Okay, so let's do one problem. Let us try to do one problem now. So suppose we have a differential equation like this. So it can contain y, the dependent variable is y here, and the independent variable is t is there, and it may contain y dash will be there, y double dash will be there. So it can be of any form. It need not be linear, it need not be homogeneous, it need not be exact, it can be any differential equation. Okay, so let us be given a differential equation like this. Okay, and it can be equal to some, what is a function of t also. That's why I just wrote it as t is equal to 0. Okay, so it can be of any form. Okay, and suppose we have some initial conditions, like for example you have y of 0 is equal to some k1, y dash of 0 is equal to some k2, etc. So suppose we have some initial conditions like this. Okay, now how to solve this? So what I will do is that the first step, I will just take the Laplace transform on both sides. So suppose I am being given a differential equation. For example, if it is like y double dash minus y is equal to maybe t square, what I will do is that first I will take the Laplace transform on both sides. Okay, that's the first step. Okay, so it will be like L of y double dash minus L of y is equal to, you know, the transform of t squared is 2 factorial by s cube. So you will do it like that. Okay, then what I will do is that here I will apply the differentiation formula to convert the L of y double dash into L of y. So when I apply differentiation formula, it will be like s square into L of y minus s into y of 0 minus y dash of 0 minus L of y, which is equal to this 2 factorial by s cube. Okay, when we do the problem, you'll understand. So first step, apply the Laplace transform on both sides. Second step, apply differentiation formulas. So once you apply differentiation formulas, you can see the initial conditions here. Y of 0 is there, y dash of 0 is there. So you can give those values here. So you can give the values and you will get some constants here. Okay, so you can give the initial conditions here. So in this left hand side, you can see that you will have a term involving L of y, and it may contain some factors like s square minus 1 plus some factor of s will be there, which is equal to this 2 factorial by s cube. Okay. In the next step, what I will do is that I will only keep this L of y in the LHS. Rest everything I will bring to RHS. So I'll just keep L of y in the LHS and rest everything will be brought to RHS. Okay, so the solution will ultimately be obtained by taking. So actually, what is the solution to the differential equation? The solution to the differential equation is actually the equation of the form y is equal to some function of t, right? Okay, so when you are asked to find a solution, you have to find the value of y which satisfies that. So that is what we want. So what I will do is that once I get L of y, if I just take the inverse transform, I will get the value of y. If I take the inverse transform of the RHS, so that is the basic idea. Okay, so let me run through it once again. Suppose you have a differential equation of this form. You need a solution. The solution should be of the form y is equal to some function of t. So what I will do, I will take the equation and then I will apply Laplace transform on both sides. Okay, so when I apply Laplace transform, what will happen? It will be, it will have some terms involving L of y double dash would be there, L of y dash would be there, L of y would be there, and some terms involving s would be here. Okay, then what I will do is that I will apply the differential formulas and convert all this L of y double dash, L of y dash, etc. into L of y itself. Okay, using the differentiation formulas plus the initial conditions. Okay, so in the LHS you will have L of y into something plus maybe some factor of s which is equal to this thing. Okay, the next step what I will do is that I will just keep L of y in the LHS and take all the other things to the RHS. Okay, so now we will get the value of L of y in terms of this s. So now if you take inverse Laplace transform using the known methods, you will finally obtain the value of y. Okay, that is the simple process. So I hope it is clear. Take the differential equation, apply Laplace transforms, then what will you do? Then write L or the apply differentiation formulas to write L of y, and then you apply the inverse Laplace transform to obtain your y. So you will have all the methods would be coming in a single problem. Okay, so this is a very simple thing. It's just that when you do the problem, you'll understand it better. Okay, so as I told you, these are the steps involved. First, we take Laplace transform on both sides. We use differentiation formulas and initial conditions to express L of y in terms of s. Then we will take the inverse Laplace transform to obtain the required solution. Okay, now let us try to do one problem here. Suppose you are being given a differential equation like this: y double dash minus y is equal to. It's a simple equation. You can use direct methods also, but let us try to do this method, analyze this problem using Laplace transform. Suppose you are given like this. So the first step what is that I will do is that I will write the equation. It is y double dash minus y is equal to 2. Okay, then I will apply Laplace transform on both sides. So what it is? It will be simply L of y double dash minus y is equal to L of t. Okay, which is simply 1 by s square, or by linearity it will simply be L of y double dash minus L of y is equal to 1 by s square. Okay, now we will apply differentiation formulas. What is L of y double dash? It is simply s square into L of y minus y of 0 minus s into y of 0 minus y dash of 0 minus L of y which is equal to 1 by s square. Okay, now I will give the initial conditions here. What is y of 0? Y of 0 is 1, y dash of 0 is 1. So I will get here as, so it's if I combine this L of y terms, it is simply s square minus 1, L of y into s square minus 1 minus s into y of 0 is 1. Okay, minus y dash of 0 is again 1, which is equal to 1 by s square, or my L of y into s square minus 1 is equal to s plus 1 plus 1 by s square, or now my L of y is simply, it is s plus 1 by s square minus 1 plus 1 by s square into s square minus 1. Okay, or I can simplify it again. It is simply L of y is equal to 1 by s minus 1 plus 1 by s square into s square minus 1. Okay, so this is my L of y. So please run through the steps again. Write the differential equation, apply Laplace transform, apply the differentiation formulas, give the initial conditions to obtain the value of L of y in terms of s. Okay, now to find the solution, what you have to do is just apply the inverse Laplace transform. You will get the value of L of y. Just the value of y. So what will you do here? So now this is the value we have obtained till this much. Okay, these were the steps which you have done till now. Okay, and you have simplified this and you have obtained this value. Okay, now how will you find inverse Laplace transform? It's a very simple thing. When you take inverse Laplace transform, you will get the value of y is equal to, what's inverse Laplace transform? 1 by s minus 1. It is simply e raised to t plus, I don't know it directly, you can use any methods, you can use integration or you can use partial fractions also. So let me use it now. Suppose if I am using integration, what it will be? First I will find the inverse Laplace transform 1 by s square minus 1. What is inverse Laplace transform 1 by s square minus 1? It is simply sin ht. So what is the inverse Laplace transform of 1 by s into s square minus 1? It is simply integral 0 to t sin ht dt. What is it? It is simply cos ht in the limits 0 to t, that is cos ht minus cos h0, which is 1. Okay, I hope you know the value. The value of cos hx is e raised to x plus e raised to minus x by 2. So apply those things, you will get the value is 1. Okay, now to obtain the value of inverse Laplace transform this one, I have to integrate again this cos ht minus 1 dt in the limit 0 to t. What is it? Again it will get this as simply sin ht minus t in the limit 0 to t. So when you apply, give it here, it is sin ht minus t. Sin h0 is 0, t is 0. So the final value would be simply e raised to t plus sin ht minus t. Okay, so as I've seen, you should be very clear with the value methods of doing inverse Laplace transform. Only then you can solve these type of problems. Okay, so that is clear. Or you can use, I'll give you another method also. You can also use partial fractions here. Okay, so this 1 by s square into s square minus 1 can actually be split into, I think it can, if you just rearrange it a bit, you can split into 1 by s square minus 1 minus 1 by s square, right? So if you just take the LCM, you can say that s square minus s square plus 1. Okay, so you can split it into two like this. Now this is actually, what is this? This is actually the inverse Laplace transform of 1 by s square minus 1 is sin ht, and the inverse Laplace transform of 1 by s square is t. Okay, so using partial fractions approach also you can do the problem. Okay, and again I will teach you one more method called convolution in the last session. So in that way also, so there are many ways to solve this problem, finding the inverse Laplace transform. Okay, but you should know any one method. That's the important thing here. Okay, so this is the method here. So when you apply any of these methods, you will get the final solution as simply e raised to t plus sin ht minus t. Okay, I hope now it is clear. So what are the steps again? First step, take the Laplace transform on both sides. Then next step, apply differentiation formulas and the initial conditions to get the value of L of y is equal to some term of s. Now you apply the inverse Laplace transform, you will get the value of y. Okay, because the solution you are looking is actually the value of y is equal to something. Okay, and if you might have noticed, there is one drawback to this method, that is your initial condition should always be around the point y of 0. The initial condition should always be around the point y of 0. Why is it so? Because when you apply the differentiation formula always contains this s into y of 0 minus y dash of 0. Okay, so the initial condition for this problem should always be at the point y of 0. Okay, but still if there are some other problems where you have y dash of maybe y of 1, y dash of 1, etc., we will still be able to do those problems by making a simple transformation, which we will be doing in this session itself. So I'll do those problems also where the initial condition is different from the point 0. Okay, so for now, to solve these problems, remember you need to have the initial condition at y at 0. Only then you can apply the differentiation formula, because the differentiation formula contains this y of 0 and y dash of 0. Okay, so that you have to please note it. Okay, so that's it. So as I told you, this is the initial condition should be at t is equal to 0 to directly use the differentiation formula. Okay, so even if it is any other point also, we will do those one, but we'll make a slight tweak to this method. Okay, that I'll explain it to you in the end of this session. Okay, now let us do one more problem here. So please try to do this problem with me. Please try to do it by yourself. You are being given a different dimensional equation like this. So it is simply y double dash plus 3y dash plus 2y is equal to e raised to t. Okay, so what will you do? You apply Laplace transform on both sides. So you will get this as L of y double dash plus 3 into L of y dash plus 2 into L of y, which is equal to e raised to is 1 by s minus 1. Okay, so please try to do it with me, only then you will understand. So you are applying Laplace transform on both sides and you are applying the linearity property. Okay, now you apply the initial condition. So what is it? It's simply s square into L of y minus s into y of 0 minus y dash of 0 plus 3 into, don't forget to put this bracket here, it is simply s into L of y minus y of 0. Okay, plus 2 into L of y, which is equal to 1 by s minus 1. Okay, now you apply the initial condition. So before that, let me bring all the L of y terms together. So we'll be getting it as s square plus 3s plus 2 into L of y. Okay, minus s into y of 0. What is the value of y of 0? Y of 0 is 1. So we'll have minus s minus y dash of 0 is 0. So this will become 0 here. Okay, again you have a y of 0 here. So that is minus 3 into 1. Okay, so I think that's it. Plus 1 by s minus 1. Okay, so I hope it is it. So I think it is correct. So please correct me if I am wrong. So finally I'll put L of y to one side. So on the right hand side we will have s plus 3 by s square plus 3s plus 2. Okay, plus 1 by s minus 1 into s square plus 3s plus 2. Okay, so this is your L of y. Now if you take the inverse Laplace transform, you can easily find out the answer. So I hope this is clear to you. You apply the Laplace transform on both sides, and then you give the initial conditions and keep L of y on your LHS and bring all the terms to your right hand side. Okay, I hope it is clear. Okay, now how will you find inverse Laplace transform? Okay, so there are many methods are there. So convolution we have not yet studied. You could easily use convolution. Since we have not studied that method, I will use partial fractions here. So before I use partial fractions, maybe I could simplify it a bit. So that is by, yeah. So if I take the LCM, so this will be simply be, it is, if you take LCM here, it is actually be s plus 3 into s minus 1. So it is simply s plus 3 into s minus 1 plus 1 by s square plus 3s plus 2 into s minus 1 here. So when you multiply, you'll get this as s square plus 2s minus 3 plus 1. So s square plus 2s minus 2 by, again denominator will have s minus 1, and similarly you can split it into s plus 2 into s plus 1 here. So this is your L of y here. So what is the benefit of this? So if you can see this, if I write in this form, you can use partial fractions directly because the denominator has degree 3 and the numerator has degree 2. So you can easily split it into 3 different parts. Like you can split it into some a by s minus 1 plus some b by s plus 2 plus c by s plus 1. Okay, so we can easily use partial fractions to split the denominator. Okay, let me emphasize that there are also other methods to do this problem, but still I'll be using this method because this convolution method is required, but we have not been introduced to that, so we'll only introduce in the last session. So if it is, you can do it directly, but since we have not studied that, I'll use the partial fraction method here. Okay, so I hope this is clear. Now let us try to find the inverse Laplace transform. Okay, so before that, this is the one which we have got here, and this I'll be splitting it as maybe a by s minus 1 plus b by s plus 1 plus c by s plus 2. Let us try to find the value of this a, b and s. Okay, how will you find it out? You write it like this. So when you write your LHS, your numerator will be like this. When you take the LCM, your numerator will become like this. You substitute some values here. So when you put s is equal to minus 1, what will you get? This will become 0. This will become 0. You will be getting s. When s is minus 1, you will get minus 1 minus 2 minus 2, right? 1 minus 2 minus 2 is equal to your b will have b into minus 2 plus again minus 1 plus 2 again 1. So you will get the value of b as minus 4 plus 1, that is minus 3. So I think the value of b is actually 3 by 2. Okay, I'm not clear, but try to do that. Again, you put the value of s as minus 2, try to find the value of the c here, you'll get the value of c, and then finally you put s as the value of s as 1, you'll get the value of 1 here. So you substitute this and then find those values. So the values is like this. The values are the value of a is actually 1 by 6, value of b is 3 by 2, the value of c is 2 by 3. Okay, so you can just substitute the values and then find it out. Now once you have got them, now it is very easy to find the inverse Laplace transform. Why? Now if you take the inverse Laplace transform, what will you get? The value of y will be simply y is equal to 1 by 6 due to linearity. The inverse transform of 1 by s minus 1 is e raised to t, again plus 3 by 2 into the inverse transform of 1 by s plus 1 is e raised to minus t. Okay, minus 2 by 3 into inverse transform of 1 by s plus 2 is again e raised to minus 2t. So very straightforward calculation, you can easily find it out. Okay, so this is another method of using the Laplace transform. Only thing is that you have to be well versed with finding the methods for inverse Laplace transform. Only then you will understand these methods. Okay, now let us look at some more practice problems here. So here are some practice problems for you. So please try to do these problems also. It's a very simple thing. The first step is apply Laplace transform on both sides. You apply the differentiation formulas to bring everything to L of y form, and then you substitute the values. Okay, so that is how you solve initial value problems using Laplace transform. Okay, now next what I am going to do is that suppose your initial value problems has some other value of t, not y of 0. Suppose you will have some y of 1. Okay, suppose your initial point t naught is greater than 0. Okay, so suppose your initial, so usually your initial point t naught is 0. Suppose your initial point t naught is greater than 0. So what will you do in that case? So in that case, what I will do is that I will just employ a simple what is a transformation. I will change the variable t to a t tilde. I'll change the variable to t tilde, so that when t is equal to t naught, okay, my t tilde will be 0. So when t is t naught, my t tilde will be 0. So I'll convert the problem which is in terms of t to a problem in terms of t tilde in such a way that when t is in t naught, when t is the initial point, my t tilde will always be 0. Okay, so then I can solve the problem in terms of t tilde using the earlier method which I studied, because earlier method works for the initial point where it is 0. So it will work for the earlier, like the earlier method will work. So I'll just convert the problem in terms of t to a problem in terms of t tilde, so that when t is this initial point is different from 0, this t tilde will be exactly in terms of the 0, and now the problem will reduce to the original type 1, and then we will do it. So just like our Cauchy-Euler equation problems, we'll just transform the equation. That's what I'm going to do. So how will you transform it? It's a very simple thing. I'll just substitute this t is equal to t tilde plus this t naught. Okay, so remember what will happen if your t is t naught. What will happen if your t is t naught? When t is t naught, you can see that your t tilde should be 0, right? So when t is t naught, we will have t tilde plus t naught, or your t tilde is equal to 0. So my substitution is this one. Don't forget this is very important. So I'll substitute t is equal to t tilde plus t naught. Okay, so that is, suppose your equation is like this. For example, you have to solve y double dash minus y is equal to maybe t, your t of 0 is equal to 1, t of 2 is equal to 1, t dash of 2 is equal to 0. I'll substitute t is equal to t tilde plus 2. So looking at the initial condition itself, I'll just write down the equation. So it's very important to understand that substitution. Okay, so I'll just substitute. Now when you substitute it, accordingly your equation also there will be some change, because your equation entire y is in terms of this t only, right? So your y was in terms of t. So when I substitute y of t in terms of this t tilde, so now t has been replaced by t tilde. So it will be y of t tilde plus t naught. Now it will be y of t tilde plus t naught. So your entire equation should also change, because the variable y also will be changing now, because I have just changed the variable t to t tilde plus this t naught. So suppose your y was like sine t. So I'm just telling for your hypothetical purpose, plus e raised to t. When t has been changed, your y also will become like e raised to sine t plus t tilde plus t naught plus e raised to t tilde plus. So for in every place of t you will have this t tilde plus t naught. Okay, so I will have to write t tilde plus t naught for every occurrence of this y. So in order to shorten the process, I will call this as simply y tilde of t tilde. I'll just call this quantity as y tilde of t tilde. Okay, so this y of t is now being called as y tilde of t tilde for just convenience of notation. Okay, so what I will do is that so your equation will have now y dash of t would be there. What will happen to this y dash of t? Okay, so y dash of t is actually d by dt of this y of t. Okay, now or this is simply d by dt of this y tilde t. This is not required for your derivation, is not required for you, but for your understanding I'm just telling you what is being changed here. Okay, so it is simply d by dt of y tilde of t tilde, or this is actually d by d tilde of y tilde t tilde into d tilde by dt, d tilde by dt. Okay, so using the chain rule here. Okay, or this I can write this as simply y tilde dash t tilde, because I am just differentiating y tilde in terms of t tilde itself. So simply it will become y tilde dash of t tilde dash. And what is this d tilde dash of dt? Your t is actually t tilde plus some constant, so your d tilde by dt will simply be 1. Okay, so that means your y dash of t is actually y tilde dash of t tilde, your y of t will simply be y tilde of t tilde. That means in your equation, just try to understand this. Suppose your equation is in terms of y double dash of y is equal to some t. What will be changing when you terms and terms and terms? What will be changing when you change in terms of this tilde? Your y double dash will simply become y tilde double dash minus simply y tilde is equal to, only for this t there will be changed. This t will be changed to your t tilde plus t naught. Okay, rest everything will be like your y of 0 here will be like y of some t naught will simply be like y tilde of this 0 and y tilde of dash of this 0. Okay, so when you do the problem, you'll understand. So just remember these quantities here. I'm just changing the variable t to t tilde plus t naught. What will happen when I change the t variable from t tilde to t to t tilde? Your y will be changed to y tilde only, and also your y dash will be changed to simply y tilde dash, and your y double dash will be changed to y tilde double dash. Remember that. Okay, rest everything will be just the same. Only difference which will be coming from in your equation is in the terms of this t. The value of t will change to t tilde plus t naught. In the RHS, in the LHS, everything will be just the same. Okay, when you do the problem, you'll understand. I will give you a problem also. We'll try to understand that here. Okay, so that is it. So as I told you, your y dash of t is the same as y tilde dash of t dash, and everything will be like this. Okay, so once now your problem, when you convert your y of t into y tilde, what will happen is your problem will become in terms of y tilde and this t tilde. Okay, now you solve this problem in terms of y tilde, you will get the value of y tilde. Once you get the value of y tilde in terms of this t tilde, the original function y is obtained by putting the value of t. Okay, so you know the t is equal to t tilde plus t naught. So the value of t will be simply okay. So value of t tilde is actually t minus t naught. So in this equation, if I substitute back the value of this t tilde, you will get back the original function. Okay, so why was this method adopted in the first place? This method was basically adopted in the first place because you cannot use the differentiation formulas directly if your initial condition contain a point other than this 0. Suppose your initial conditions depend on the point pi. You can't use the differentiation formula directly. So what I will need is that I'll try to make the initial point as 0. For that, we are using this, what you say, this longer path, slightly longer path to just convert the problem into original form like this one. Okay, so that is the basic idea. So from this discussion, one thing should be clear to you. What I'll do is that in such problems, I'll just substitute t is equal to t tilde plus the t naught. So this is the only substitution you have to remember. Rest everything will just be the same. And for y, you replace it by y tilde, and rest everything you can do it. Okay, that is what I am going to do here. Okay, so let us try one problem now. Okay, suppose you have a problem like this. If you look at this problem, y double dash plus y is equal to 2t, y of pi by 4, so y is equal to pi by 2, y dash of pi by 4 is equal to 2 minus root 2. So you can see that this is different from earlier problems, because earlier problems it was y of 0. So but here it is not y of 0. So you cannot solve this problem directly, because when you apply the differentiation formulas, you will have to give the value of y of 0, y dash of 0, etc. So you can't do it directly. So what I will do is that I will change the variable t to t tilde. I will try t as t tilde plus your t naught is 1 by 4 pi, the point which is there. Okay, so this is my substitution. Remember the substitution. Okay, please try to write it with me, only then you will understand. So you can see that when your t is pi by 4, what is your t tilde? When your t is pi by 4, your t tilde will be 0. Okay, so that is the only thing you have to understand. Okay, now I will just change the y to y tilde everywhere. So my equation will now become, please look here, y double dash will become y tilde double dash plus y tilde. So there's nothing, there's no need to write derivation. You can just direct straightforwardly substitute it there. So it becomes y tilde double dash plus y tilde plus 2 sorry, this is equal to 2t. So your t has actually undergone a change. What is it? It has become t tilde plus 1 by 4 pi. So that is the change you have to make here. Rest everything is just same. And your y at 1 by 4 pi. So when t has become 1 by 4 pi, your tilde will be 0. That means your y tilde of 0 is pi by 2, and your y tilde dash of 0 is 2 minus root t. So if you just look at this, you can see that the problem which had a different initial point has now been converted into a problem at the initial point 0, but here the independent variable and dependent variable has been changed to t tilde and y tilde also. So you have to just make this tweak here. Let's look at the equation. Your LHS will remain the same. Only thing is that you make the change that y will be changed to some y tilde and the t should be changed to t tilde plus t naught. That's the only difference you have to do it here. Okay, rest everything is just the same. Okay, now you can solve this equation in terms of your y tilde double dash. You can apply the Laplace transform on both sides. So what will you get when I apply? So once you have understood this, you can take this equation, you can apply Laplace transform. What will you get? You will get as L of okay. So I have written here everything. That's the thing we have got here. Now I will apply Laplace transform. So you will be getting it as L of y tilde double dash plus L of y double dash is equal to 2 into, remember, don't be confused with t and t tilde. You just compute in the usual form. After all, your t and t tilde are variables. So when you apply the Laplace transform, you will be getting as before itself. The variables will be just the only thing is that the variables have changed, but the Pythagorean values would be just the same. Okay, so when you take the Laplace transform of t tilde, it is the same as taking the Laplace transform of t itself. So it is simply, you will be getting it as 2 by s square plus again you will be getting pi by 2s. Okay, so when you apply the Laplace transform of 2 into 1 by 4, 1 by 2 into pi, it is simply pi by 2s. Okay, and then you can LHS will be like s square into L of y tilde minus s into y tilde of 0 minus y tilde dash of 0. Okay, plus L of y tilde is equal to 2 by s square plus pi by 2s. Now what is y tilde of 0? Y tilde of 0 is actually 1 by 2 pi. Y tilde dash of 0 is 2 minus root t. So we'll be getting this as, I'll write this L of y tilde once again together. So it is simply L of y tilde, okay, into s square plus 1 here minus s into y tilde of 0 is pi by 2. So pi by 2 s here. Okay, similarly y tilde dash of 0 is 2 minus root 2. So we'll be getting minus 2 plus root 2 here. Your RHS is plus 2 by s square plus pi by 2s. Okay, so you can keep L of y tilde on one side and bring all terms to the right hand side. So you will be getting, so these are the things here. I will write it again once again. So when you do everything, you will be getting, what is it? Your LHS and RHS, you can bring it together. So it will be simply, I think it was, what is it here? Okay, so your L of y tilde will be equal to, what is it? It will be 2 by s square into s square plus 1 here. Okay, minus s by s square plus 1 into pi by 2 would be there. Oh, sorry. So I think it is plus, right? Yeah. Plus s by square plus 1 into pi by 2 will be there. Plus again pi by 2s into s square plus 1 would be there. And similarly, you will have plus 2 minus root 2 into s square plus 1 would be there. Okay, so you will have some terms involving s square plus 1, s into s square plus 1, etc., everything would be there. Then you have to apply the integration formulas to find those values. So that is the idea. But I hope the idea is clear to you. Please write it down by yourself. Only then you will understand how to have got these methods. Okay, now let us try to solve this problem. You just apply Laplace transform on both sides, expand it, and apply the initial conditions and bring everything in your RHS, and you write L of y tilde. I think you will get L of y tilde like this one. Okay, so your L of y tilde, so when you apply everything, it is this. This is the way. So instead of L of y tilde, I just have written it as capital Y tilde. So I think this is the quantity which you will get when you substitute everything like this. Okay, so you gave the value there, you substituted the values, you got that. Okay, now how will you find the inverse Laplace transform? So when you take the inverse Laplace transform, you will be getting the y tilde value. Okay, so how will you find it out? There is a term involving s square into s square plus 1. Before that, there is a term involving s into s square plus 1, and before that, there is a term involving just s square plus 1. Okay, so what is the inverse transform of 1 by s square plus 1 first of all? So let us write down the quantities which we know already. So the inverse transform of this one is simply pi by 2 into s by s square plus 1. So it is actually, what is it? It is cos t, right? Plus the inverse transform of this one is actually 2 minus root 2 by s square plus 1. So it is actually 2 minus root 2 into sin t, right? 2 minus root 2 into sin t. Okay. Now how will you find the inverse transform of 1 by 2 pi into s square plus 1? So I have to find inverse transform of 1 by 2 pi by s into s square plus 1. Before that, find the inverse transform of I'll just find the inverse transform of 1 by s into s square plus 1, because pi by 2 is a constant. We can use that here also. So what is the inverse transform of 1 by s into s square plus 1? First you find the inverse transform of 1 by s square plus 1, that is nothing but cos t, sin t. Okay, then you integrate it from 0 to t, just as I taught you. Integrate it from 0 to t, it is actually, what is it, minus cos t in the limits 0 to t. So we will be getting minus cos t. So it is, I think it is 1 minus cos t. So okay, so here you will be getting it as pi by 2 into 1 minus cos t will come here. Pi by 2 into 1 minus cos t will be there. So you will be getting it as pi by 2 into 1 minus cos t in this side, and this cos t and this cos t would be cancelling out. Okay, now how will you find inverse transform of this one? So for that, in order to find 1 by s square into s square plus 1, first you find the inverse transform of 1 by s into s square plus 1, which I have already found, which is 1 minus cos t. Now we integrate it from 0 to t. So it is simply t minus sin t in the limits 0 to t. So it is again t minus sin t itself. So this will be simply 2 into t minus sin t. Okay, so here also I think some things would be cancelled out. So finally you will be getting y tilde as simply so it is not t. Remember that thing also. You have here all your t's should be written as t tilde, because you are writing this in terms of y tilde only. So remember here everything should be written as cos tilde bar, sin t tilde bar, because here the dependent variable and independent variable are in terms of y tilde and t tilde. So please don't forget that this is just for computation purpose. I have written as t only. Everything should be written as t tilde itself. Okay, so when you do that, and when you substitute all these values, I think you will be getting just as we wrote out here. It is 2 t tilde minus sin t tilde. We have got that one. This one also we have got. This one also we have got. And this also we have got. And these terms would get cancelled out many terms. Minus 2 sin t tilde is there. Here plus 2 sin t tilde is there. They will get cancelled out. Again, minus pi by 2 cos t tilde is plus pi by 2 cos, so that will get cancelled out. So we will be getting this quantity. So we will be getting your y tilde as just 2 tilde plus pi by 2 minus root 2 into sin t tilde. Okay, now to get back the original function y, what I will do is that I will give the value of t tilde. Okay, so your t was actually t tilde plus, I think it was, what was the initial condition? I think it was pi by 4, right? Yeah, pi by 4. Okay, so your t tilde is simply t minus pi by 4. So in this value, give the value of t tilde as in terms of t minus pi by 4, then you will get y. So y is actually 2 into t tilde is t minus pi by 4, okay, plus pi by 2 minus root 2 into sin t minus pi by 4. Okay, so when you give that, you will get just your y is equal to 2t minus pi by 2 plus pi by 2, it will get cancelled out, minus root 2 into your sin t minus pi by 4, I can write as sin t cos pi by 4. So it is sin t cos pi by 4 minus cos t sin pi by 4. So pi by 4 value is 1 by root, cos pi by 4 and sin pi by 4 is 1 by root 2. So you get root 2, it will cancel out. So you will get as 2t minus sin t, okay, plus cos t. Okay, so that is how you will be getting this. This is likely some work is here, but usually this question and the previous question can be come for 7 marks or 8 marks also. So you have to practice it a little bit. So only thing is that you have to understand that so this is the method here. So in these type of problems, remember, for the first step you will substitute t as t tilde plus the initial point. For example, suppose in this problem I will write as t tilde plus 4. Okay, and rest everything I will just change y as y tilde double dash minus 2y tilde dash minus 3y tilde is equal to 0. Then I will apply the Laplace transform method and directly solve it in terms of y tilde. Remember, when you write y tilde, you should write in terms of t tilde. Okay, when you take the inverse Laplace transforms, and then also remember, to obtain y, what you will do is that in the value of y tilde, I will just substitute the value of t tilde, which is simply t minus 4 in this case. Okay, so these problems also, they can come for an examination for 7 marks or 8 marks. So they are very important. So shifted data problems are also very important. So essentially the idea is for of initial value problems only. Only thing is that you're just tweaking a little bit so in order to accommodate these type of initial conditions also. Okay, so I hope it is clear. So please try to do every problem from previous section also. These are very important problems from the Laplace transform, because these are the problems which are coming for 8 markers in your examination. Okay, so these initial value problems, definitely it will come for 8 markers from the examination. Please try to do every problem, and if you have any doubt, please comment on the chat box, or you can also message me and we'll try to discuss it later. Okay, thank you.